In section 2.6, we're still looking at composite functions, but we're going to look at them more in the application situation where we're doing some problem solving. Our only objective here is solving problems using composite functions. All right, so we're starting off, there's like a huge sale advertisement. It says 60 to 70% off when you take an additional 40% off already reduced prices. I'm sure you've all seen signs similar to this in stores before. So last week, a coat that we wanted was on sale for 25% off its original price, and now we can get the coat for 40% less than last week's price. So we want to compute the cost of the coat. So if it was originally $80 and we saved 25%, let's do the calculation on this one too, just to figure out where these numbers are coming from. Let me move this maybe up here. Shrink this up a little bit. Okay, so if it was $80, if I saved 25%, that's a savings of $20. So 80 minus 20 is $60, so it would still have cost me $60, right? And then I take my $60 and I'm going to save 40%, which is 0.40. And so I would have saved $24. So 60 minus 24 is I would have still had to pay $36. That's where these numbers are coming from. Okay. So again, if my coat starts off at $100, and first of all, I save 25%, that means I save $25. So I'm going to have to pay $75. This 100 minus 25 is 75. Okay, so I'm going to keep a note that this is 25% off. And this row over here is, or column, is 40% off. So if I paid $75, then 40% off would have been $30 off. So my 70 minus 30 would be, I would be paying, oops, I was supposed to say 75, of course. I would be paying $45 for the coat. $45 coat? $45 doesn't sound bad. And then again, we could do this with the next one as well. If it was $120 and I saved 25%, then I'm saving $30, so I'm still paying $90. And then 90 times 40, it's supposed to hit times there, there we go, time. My book is on my keyboard just a little bit, so it was causing a little problem there. All right, $90 times 40% off, I'm going to save $36, and so I'm going to be ending up paying $54. And the last one, $140 times 25%, I got to put the 0 up there. I'm going to save $35, so I'm going to end up paying $105. And then I get my 40% off of my $105. And I saved another $42. And so I end up paying $63. Okay. So that's one way to have done the calculations on these, perhaps the long way. If I was to consider for part B, what percent of the original price have you paid for the coat during last week's sale, right? If it's 25% off, this means that out of 100%, you paid 75%, right? 25% off means 75% paid. So if I wanted to compute these directly, I could take the coat's cost and I could multiply it by 0.75. So the sale price would be y equals 0.75x. Let's just check that for one of them. We can just check it for the last one on the table. If I had taken the 140 times 0.75, it would have gotten me the 105 directly instead of having to get the 35 and subtract that off, right? So 105 directly if you said 75% of 140. Okay. Similarly, when I have 40% off, how much do I pay? So 100% minus 40% is 60% paid. So this equation would be Z, the amount paid at the end, is 60% of Y, which is last week's price. So according to our chart, we have X, we have Y, and we have Z for each of these columns. You can write that underneath. These are all of our X's, these are all of our Y's, and these are all of our Z's. So just again, one more instance where we can just check this. If I did my $105 times 0.6, that's going to get us my $63. And remember, $63 was our final cost for the coat that's in the bottom row right here. So 60% of the 105. Okay. Moving my decimals away. Now, this is a composition. So when we take the original price, we first get the output that is last week's price, and then that output becomes the input for this week's price. So we're doing a composition right here. So the composition, if we call the first function f of x and the second function g of y, so I'll rename this function up here f of x like they've asked me to do, and rename this one g of y. Then the composition that I need is g of f of x, because I need to do the f of x function first. It's my innermost function. That'll go on the inside to be done first. And I want g to happen last. Okay, so if I do the f of g of x function, x is going to go into f first. That computes last week's price. The result of last week's price then goes into the function g. Okay, so the g function, that is 0.60y, so 0.60 times f of x. And the f of x function is 0.75 times x. And so I'm going to multiply those two numbers together. If I take 0.6 times 0.75, that gives me 0.45. For the simplified function, right? I just used my calculator, I didn't pull it over to the screen, but 0.6 times 0.75 is 0.45, so 0.45x. All right, now on to my next page. My answer should imply a 55% savings, does it? So remember that percentage, that 60% was 60% paid, the 75% was 75% paid. So this g of f of x composition, this 0.45x that we have here, this is the percent paid. So if we have paid 45%, then 100 minus 45%, 100 minus 45 is 55. So that should imply 55% saved. So this would be yes. That this 45% paid right here, implies that we have saved 55%. Okay, I'm just going to go ahead and say same right here, since we already went ahead and did the function composition. They just wanted me to multiply stuff, but that was the function composition, so we did it already. Okay. So part D, they want us to compute using the single step equation the final price for each of these coats. Notice that each of these are the same as they were before. So I'm going to go ahead and write myself a new function for this 45x. I think I already have my functions. No, up here I didn't do functions. I just did all those numbers, which is a bunch of time. So let me just call it h. I've already used the names f and g, so I'm going to have a new function just called h of x, and it's going to equal that 0.45x. If I make myself a quick little table, I can get these to compute. And I want to compute for an $80 coat, $100 coat, $120 coat, and $140 coat. And I'm going to compute these in my new function, h of x. All right, so if I shrink this window down a little bit, we can see that our $8 coat is going to cost $36. Our $100 coat is going to cost $45. Our $120 coat is going to cost $54, and our $140 coat is going to cost $63. And these numbers should be exactly identical to the ones that we got before when we did the composition one function at a time, took the input, got the middle function's output, took the middle function's output as the input to the second function to get the cumulative output. All right, now it doesn't ask me to, and I really wish it would, but I want to get back to this original question of this sale says that I'm saving 60 to 70% off. And that's because I have a 40% sale and a 25% sale. And so the person who wrote this sign was thinking, oh yeah, well, 40 plus 25, that's 65. So you save 65%. But that's not correct. You don't save 65%. They don't add. I really only saved 55%. So this was a false advertisement. It was done by an incorrect mathematical calculation. I'm saving 55% because they don't add. Percentages don't add. The two functions are composed, and because they're both multiplication functions, it turns into a multiplication when I do the computation there.